Yo, yo, yo. What's up? Good morning, good morning. So the plan today is to continue with the bisection tool, or it's actually a mesh parser tool, which we are going to use. We're going to rename it. It's going to be used to procedurally generate a lot of different meshes depending on setup. But for now, we're doing bisecting. Good morning, Harukanan. Good morning, good morning. So the current state of it is this. It's a very simple type of slicer. So we slice based on a plane and we fill the cap like this. It's not perfect, but it works. But right now we just have this one as a mesh bisector clean test script. Yo, what's up, Derek? I want to implement this functionality as using our primitives, so like edge, polygon, triangle, vertex, and our mesh parser. Harukanan, yeah, it's pretty useful. Like, when it comes to our first creature, the the creature called Sten, I thought about it. So like, it's gonna look like a stone, definitely. So we have these two meshes right now, and these meshes are extremely simple, but they look pretty good. And the idea is to generate these meshes on creature spawn on a secondary thread, and we're gonna do it by slicing. So sometimes we generate a we generate a sphere and then we slice it, and sometimes we generate a box and slice it, and hopefully we will get something pretty and unique. I think it's gonna be real good. And that's just the first use case for this one. Like, if this happens to be the only use case for the bisect functionality, I'm gonna be happy either way because I'm fine with it. But I'm pretty sure we will find some other useful stuff to do with it as well. Harukanan, IKEA name, 100% IKEA name. Yes. So, some of these methods here, actually we have a pretty good task list already here. We added UVs yesterday to primitives vertex. So we have it here like this. So pretty much mesh parser and these primitives, they take the data we have in Unity engine.mesh and store them and structure them in a more parsable way, pretty much. So we added UV here. We also changed get hash code from using the index to position, normal, and UV. We need to do it now when we are generating meshes instead of just taking a mesh and parsing it. The biggest backside of doing it like this is way more expensive than just returning an integer. Hopefully still doable though. Yes. And then we want to implement mesh parser slice, combine, add, and get mesh, and then primitives triangle slice. So I think we're gonna start with this one. So here we go. And then again, we're gonna use don't we have it here? Slice, cut triangle. I think it's this one. Plane, V0, V1, V2, N0, N1, N2, UV0, 1, 2. So this, all of this are stuff that we store all of this in one struct, vertex. Let's see, and then we want to send in the positive. I don't think we're not going to do this just yet. Yeah, in our case, I don't want to send anything like that in. I want to return an array of triangles. Although I wonder if positive and negative so maybe we want to return it as a tuple. Maybe. Actually, that is probably the better way to do it, isn't it? Can we do it like this? Mm. Positive, negative, slice. So where do we have it? Cut triangle, and then we have verts, norms, UVs. We repackage it like this, and positive vertices, negative vertices, positive normals, positive UVs, negative UVs. Yo, what's up, Cooler SK? Rocka gonna give the critters IKEA-style names as to confuse Nintendo assassins. I guess that's just like a... That's not the main reason, but it's like a... what's the word I'm looking for? A positive side effect of it. Honestly, I'm just paying tribute to my heritage by naming them like IKEA-style furniture. And my heritage being that I was almost born in the city where IKEA was created. Okay, so here we loop through them and create... Okay, we create edges here, don't we? VAB... Yeah, I think we do. Sides. Interesting in sides. We're gonna We're gonna check this one out. Dang old Swedishism, I guess. Swedishism. S0 get side. Ah, yeah. Okay. Get side. This one I'm interested in. Whoa. Plane. Where do we have the plane? Oh yeah. Unity Engine actually has a plane. Yeah, we want to do extra stuff with our planes. We're not going to use Unity engines. Plane. The only thing, or the bad thing with that then, is that we're going to have to implement get side ourselves. But that's okay. Isn't this... We just do a dot product, don't we? Plane Unity. Get side. Otherwise, yeah, okay. Yeah, I guess it's only a... Yo, what's up, Apukas? Fucking great feedback you gave in the Discord, by the way, Apukas. I was just checking it out real quick because I was doing some other work. I'm gonna read it more thoroughly, but damn. Very nice. Cooler's Care. Remember the ad from years ago of IKEA where there was a woman looking at furniture and saying random Swedish words at them? And narrator is like, this our name designer, she makes sure to give unique names to all of our pieces just so you can find the one you like. And at the end of the speech by narrator, you can see woman just saying some Swedish word over and over while pointing pen at a vase. Like, this stream turned out to be like an ad for IKEA today. Where I'm just reading up. Where I'm reading Cooler SK's memory of an IKEA commercial from way back when. I don't remember any IKEA commercials, actually. Okay, let's see. Get side. Whoa. 1 sec. Okay. Plane. Okay, I think I wanna... Get contains... Kurosuke, I think it might have been a vase. Actually, I'm gonna go look for this IKEA commercial after. Public bool is point on positive side. return. Yeah, we probably want a point here as well. Return vector3 dot less than size, I don't think, but bigger than 0 maybe. Right? Point minus origin. And normal. Yeah, I think that's how we want to do it. Cooler SK, but Dad was definitely poking fun at the name convention, because over here it was considered to be weird in a silly way. Yeah, I guess it could. I think it's a very clean... I think it's a pretty cool naming convention, personally. Apukas, thank you. At first glance, the game seemed like an isometric, so the feedback is more towards designing the isometric, but also some tips can be applied to the first person. Yeah, 100%. Yeah, the screenshot was from isometric view, or top-down isometric, but it's a first person. But yeah, like the tips concerning like broken vase pieces and like dirt and small stuff like papers is a pretty good universal tip. Okay, is point on positive side. Okay, we're gonna leave that one like that, and let's see. Get side, get side, get side. Yeah, and then we want to check if all of them are on the positive side. Yeah. Okay, but now we are in cut triangle, so we don't care about that. But so we create edges, right? This is just edges, right? And we check if side A is on positive, then we add the vertex, the normal, and the UV here. Otherwise, we add it to negative. And then we check if the edge is split, then we do some weird stuff. We're going to get to that one. And then we check if positive count is bigger than 3, triangulate. If negative, triangulate. But could we end up with positive V being less than 3? I mean, after this one, we add new vertices. I guess this happens if we send in a triangle that is not cut by the plane, maybe. Maybe. Apukas and also directing the player where to go also helps. Yeah, that is... I love stuff like this. So, like, taking the easy way out is by just using some weird UI element like an arrow to direct the player. Boring, but works. But fuck, when the environment is designed with minor details like that, like the rubble and garbage making like a path-ish to guide the player. Fuck, that's beautiful. Okay, I think we can do this one pretty easily. Although, okay, I wanna split edge as well. The only problem I see now is that we want to support like partial triangles with, like, we want to build the triangle as we go. That might be, actually maybe it's not that hard. And we can skip this one, can't we? I want to go off, quote unquote, off script here quite a lot. I think we can skip this for loop. We can utilize the edges. I think we can make this one way prettier, maybe. Intersecting collider. Okay, I wanna like, don't I have this calculation in util math geometry? Get intersection point between plane and line. Like, I'm wondering why we're yeah, we want to get T. Yeah, but we get T here, so that's okay. Okay, so we're gonna do this. We're gonna add is intersecting plane. Or maybe not is intersecting plane. Or maybe. Let's do it. Is intersecting plane. But we don't want to use Unity Engine here. We want to use game.misc. dot shapes plane. And we're going to return -1 if it doesn't intersect. If it does intersect, we return where it intersects, pretty much. This tells me that we're assuming it returns a bool, but we're going to do it like this. And I want to use util math, and we're going to use this one. Yes. Line direction, I think. Forget that I don't. Yeah, binormal is our direction. And then we do if dot product bigger than turn t. Or actually, is intersecting plane. Maybe we should do or is it out? I always forget. Ref. And it's ref, right? Yes. Yeah, and then we continue and do t is equal to dot bit. Yeah, we don't have dot here. We do vector 3 dot dot. Plane normal. So plane dot normal. Plane dot origin minus line point. Fuck, which point do we use? It's the start point, I think. Or maybe it doesn't really. Let's do start point. So edge, we're going to use v1 dot position. And then we divide this with the dot product. Yo, what's up, Geralt? Good morning, good morning, good morning. Yeah, and then I want to return true, like this. I think this is a pretty good way of doing it. And then we're going to add a method for getting getting a new vertex at T, pretty much. So public vertex at vertex, or create vertex. And new vertex. Position normal UV. So position is AB. So v1 dot position, v2 dot position T. That's our position. And we're gonna do this with normal as well. We're gonna do it with all of them, I guess. There we are. So let's just bam, bam, bam. Or actually, do we only have... Yeah, and then we have index. Index is the last one, and for index, we're just gonna do -1. I think. Okay. So now we have... Whoa, 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 whoa. Cut edges. Yeah, we need to keep this one around. Yes, we do, because we're going to do cap cut later on. Cut edges. Actually, edge points, yes. Okay, beautiful. We're going to call it edge points eventually. But let's see here. Anything else we need? Triangulate here. We're gonna have to change these 1 to vertex lists as well. But I'm okay with that. Triangles per edge. This one as well. I don't think we will add just a single mesh or a single vertex to mesh parser. I think that would be stupid, and I don't think we need to do it. I'm gonna hope that we don't need to do it. Let's see. Change mesh parser. Mm. Okay, I do want to try this one. Test it. Actually, I'm gonna add it as a to-do. Would be nice to have some nice automatic tests for this one actually. But for now, I'm just gonna continue under the assumption that everything is a-okay and we have no problems at all. Is intersecting plane, create vertex. Okay, let's commit this real quick. I'm gonna commit this and we're gonna commit, yeah, that's the only thing we have for now. Okay. This one is actually let's just create this one real quick. Change it real quick. Mesh parser. Let's do this. That's about it, right? I think. And let's commit that real quick. Okay, great. Then we have that one done as well. Okay, let's continue with this one. Triangle positive, triangle negative is what we want to return. And we send in a plane. Triangle, triangle, triangle. Let's see. So what the fuck is this? Yeah, we just create edges here, right? Yeah, I'm pretty sure. So we don't need to do this. We don't need to do this. Can't we just do... I think we can just do this. Let's see. Or... yeah, we're gonna do int. I don't know if we need the indexing, but less than... okay, fuck it. Let's hope we don't need the indexing. For each edge E in get edges. So this is pretty much the equivalent of this, I reckon. And this is so fucking beautiful, I think. This is beautiful. Or is it? One sec. What happens with... so here we check if side A, so the beginning of the edge, is on the positive side of the plane. If so, we add it in positive, otherwise we add it in negative. But this is just 1 point. Oh, yeah. We just care about vertices and then we triangulate here. Fuck, do I want to triangulate instantly? Maybe we do. Yeah, we do. Okay, I think we can do this. But we're gonna have to instantiate a incomplete triangle, I think. Maybe that's not too bad. So we check V1 when it's the initial, then we check V. Okay, I get it, I get it. Triangle struct. Makes no sense to instantiate an incomplete struct. Can we do this in one go? Maybe we can, maybe we can, maybe we can. One sec. A plane splitting a triangle can only or will split two edges always, right? Yo, what's up, Spires? Thank you, appreciate it, appreciate it. Yeah, I'm trying to figure out if we split a triangle with a plane, it has to split two edges, right? Okay, let's create a triangle vertex list of vertex. We're not, let's try and do it without. Okay, and we're not going to do for each. We're just going to write it out. How to count on two edges or one edge if the plane intersects a vertex. I had a similar question and answer a few weeks back, I think. Is it really an intersection? in that case, yeah, I guess it. Yeah, I guess maybe, but it doesn't cut it, at least. Ah. It's a good question, but let's keep it in mind. So I'm thinking if we can just do... Yeah, I think unfortunately we're gonna have to do list vertex positive vertices list. Let's instantiate it as well. Negative vertices. And then then we do this one, which I removed, E in get edges. And then we do, I want to check, so we do a check. We do it like, can we do if E dot is intersecting plane and ref float T. Can we define it here? Maybe not. So what I'm doing here is do we still want to do, yeah, let's do it. If E dot v1 or plane dot is point on positive side, E dot v1 dot position, else positive vertices add E dot v1, otherwise E dot v. And then we check if it intersects. If it intersects, we're gonna do something. We're gonna calculate the intersection point. In fact, that's pretty much it. And then we'll triangle it. So this is, I'm questioning this one as well. This can only happen if the plane doesn't intersect or cut the triangle, or if we have one of those very specific cases, right? Maybe we want to have a boolean here, or a flag, if it's a... Is it a... like acceptable triangle? Or complete? Or... token. Well, what is a good term for that? So if we were to instantiate a triangle where v1 is equal to v2 is equal to v3, that's not a acceptable triangle, but valid. Valid, maybe. Valid might very much be the best word. Yeah, I think so. So we are gonna do... Okay, now I want to add this one to... Add bool valid to... But then we're gonna have to... Every time we change any of these, we're gonna have to check, get random point. But do we want to change them? Maybe we can make them... I want to add it. Add... Question then is, if we do... this, do we get any errors? Because then we're forced to use a constructor and we can check valid in constructor. So I think that's good. So let's do area normal public bool valid. And valid v1 is not equal to v2. And v2 is not equal to v3. And v3 is not equal to v1, right? Because what I want to do now is add constructor so I want to add a public triangle vertex list vertex vertices, and here we are just gonna check if it's bigger than 2. But can't we call shit? Getting how it is. Can we call this one here? Can we do? I want to do this, but we want to do shit. Can we do it like... this? I mean, I guess we could do it like this, couldn't we? Oh, fuck, maybe we can't. Yeah, we could probably do it like this. Vertices dot count bigger than 0. Vertices 0. Otherwise, right? Or but the problem with this way of doing it is what if we send in 2 vertices and then the third one just becomes the 0 vertex, then valid is going to be true, but we actually want this one to be false. So maybe we could do valid or invalid. Okay, so if invalid is not set, this is wrong. I want this one to be able to override. So if this one is true, this one should be set to false. Maybe it's easier to just have valid true by default. So if this one is false, so we do it like this. Because then we can do if vertices.count is not equal to 3, or if it's less than 3, or bigger than 3, bigger than or equal to 3. So this is the correct way to do it, right? If we have vertex 0, send that one in. If we have vertex 1, send that one in. If we have vertex 2, send that one in. And then we check if this one then valid. Let's start with this and see where it takes us. But I also want to create this one for if we have an array. Okay, let's commit this real quick. Both of these. So we add valid to try add 2 constructors and a valid property to primitives triangle. Because I think if we do it like this, we can probably simplify all of this quite a lot. When we try to create a mesh out of triangles, or we try to add a triangle to mesh parser, we're going to check if it's a valid triangle. If it's not valid, we don't add it. Visuals generation mesh parser primitives triangle. Okay. Ah, fuck me. Now we added a partial slice method in this commit as well. Fuck. Oh, I hate when that happens. Okay. Let's continue. So E is intersecting plane. What we want to do then is we want to calculate the point, the new point, which we can do pretty simply by just doing vertex intersection vertex is equal to E dot get calculate or create vertex T. So now we have an intersection vertex, i.e. a V1, and I'm not too sure about cut edges here. Maybe. I don't know how I want to do with this one just yet. It feels a little bit... It doesn't feel as clean to send it in and fill it up. Maybe we can do something later. I think we can do something later on. I hope we can do something later on. Mesh parser, triangles per edge. Hell yeah, we just use this one. But if we use this one, we won't be able to use... If we try and use this method on an open mesh, so a mesh that has open areas by default, then we're gonna fail. So we need to mark them in some way. Cut edges. Can we mark it intersection? Yeah, maybe we can. I mean, we could probably store them in a list outside and then compare them with this one, triangles per edges. I will see about this one. To do store okay, but we want to do positive vertices dot add intersection section vertex. And then triangulate. And we can just do this. Return new triangle, return new triangle. We do positive vertices and negative vertices. So this is equal to this, with the exception that we don't properly handle these right now, but that's okay. Hopefully we'll do it soon enough. And once again, I'm not gonna test this now. I'm just gonna continue with the assumption that it's correct. But yeah. Here's a problem, or here's something that is wrong. Our edges we do this. We sort them based on index, so we don't have the correct winding order, which means that doing this is wrong. So we might be checking this is the winding order, the edges don't have the winding order. But this is something I've been thinking about. We need to fix this. Like we should have... Draw line, draw line. This is okay. Boundary edge, draw line. So in Mesh Parser, it's all draw line. That's okay. In Edge, we do a lot of stuff. Polygon. Honestly, I'm not entirely sure we even use this one now, do we? Or actually, we use it for comparison. Hmm. Hmm. Yeah, fuck, I don't think it's point on positive side. Point on positive side, that's okay. Okay, good. We check this one. Fucking hell, I wonder if we want to skip doing this here. But we do it here. Or do we have any other way to do it here in Triangle? Because basically, let's do some drawings. So what we want to do is we take this point, now we have a plane here maybe. We take this point, we check if it's on the positive side of the plane. It is, we add it to the list. Then we check this edge. Check if it slices, it does. We calculate this point, we add it to the list, to both lists. So we check this point first, then this one, then this one. And we do it by doing edge V1, so the first vertex in an edge. And that works, that's fine and dandy. If it weren't for the fact that our current edge implementation changes or flips these depending on index. So we might actually have a triangle that looks like bam, 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 this, which means that we check this point, add it to, yeah, whatever. No, we never check this point. That is what I mean. We check this point. Twice. Once for this edge and once for this edge. And then this point here. That is not good. I wonder. I think we can probably just fix this with I think we can just fix this by going through. We check this one, and this one. Because if the plane intersects an edge, we just add that point to, but if we do it like this, like I'm thinking of doing these per vertex and then these per edges, the problem then is that we don't add them, the vertices, to these two lists in the correct winding order. So we will get a wrong result in the end anyway. I I definitely want to fix this one now. Get hash code. I still want my hash code to work like this. Equals as well. Fuck, do we use... Oh, never mind, never mind. And here I want to... Should we just do... Then I'm just thinking about doing... Is this stupid? See if it even works. Ooh. This is... Okay, interesting. Index was out of range. Yeah, okay. So... Mm. 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 Yeah, it's an issue with the capacity, right? Fuck, I always make this mistake, I think. So when we instantiate with the capacity. We tell that we roughly want, what the fuck? What? I mean, pretty cool. Or we could just do... Yeah, let's just do it like this. I don't see the reason for instantiating. And then this I want to remove again, and we add this one. Okay, let's try this then. So when we compare edges, we should still compare them the same way we did, but we store them a different way. I wonder if that comparison is gonna come back and haunt me. Eventually, we'll find out. Let's see if this one works. It takes some time, which tells me that it's hopefully does. Now it's taking a little bit too much of a time. Okay. Yeah, I think it does work. Okay, that's great. That is great. But we're gonna have to write so many tests for this system eventually. We are not doing any test-driven shit here. Okay. So edges, yeah, probably want to commit this. What did we change? Okay, triangle, anything. Yeah, here we completed this one. And mesh parser here, yeah, we fixed an issue with the lists. Okay, let's commit this one first, the mesh parser one. Or actually, let's create, yeah, this one first. And I also want to jump back to our experimental scene. fix issue related to vertices and triangles, or opacity. Okay. And then I want to add edge here. Fix edge. I think this is half edges, right? Yeah. Mm. Okay. And then triangle, fully implement triangle.slice. Yeah. We're gonna call it fully implemented right now, even though we still have this one is done. This one. Okay. Yeah. Oh no, did I? Oh, fuck it. Okay, let's continue. We already do this pretty much. I want to see add triangle. Yeah, we do. Yeah, we're gonna have to fix this eventually. But do we care about having okay, we do. We do. That's okay. Mm-hmm. Yes, we're gonna have to do this. So our mesh builder or mesh parser, we're gonna add a constructor that takes nothing. Extremely simple. Name. Okay, that's pretty much it. So then we can do, what do we have? Get, and then let's add a get random. Okay, let's add a public. But do I want to do it with tuple here as well? I think so. Mesh parser. Do I want to call it positive mesh, negative mesh? Maybe. Positive mesh parser. Negative slice. And then we loop through every triangle, create these, and then we check for each vertex in every triangle. We check if it's on the plane or split by the plane, I mean. Maybe we want to implement that in triangle as well. I think that's a good thing to have. Otherwise, we cut triangle, add it to the positive or negative match. Yeah. So what did we have? In vertex we have... Didn't I put it in vertex? Did I actually put it in plane? Yeah, maybe. Is point on positive side. I wonder if I want to calculate... Much like we have a method here, is intersecting plane for edge. I'm wondering if I want to have is intersecting plane for triangle as well. Sure, we can return a boolean, that's easy, yes or no. But I also want to, much like we return a reference float here that describes the intersection a bit more, I want to do something similar for the triangle. But what the hell would that be? You know what? Float t. I think we're just going to return a sign. Yeah, I think we are. So we're going to interpolate. think I want to define it as public bool is intersecting plane and then we do ref float sign. Fuck, that doesn't make sense. If we're intersecting it, sign should be positive and negative. But maybe, like, if we compare it to edge, float t doesn't make much sense if this one is false. So if this one returns false, that's when this one makes sense. If it returns true, it doesn't make sense. While it's the opposite here, but maybe that's okay. I mean, we could do this as a boolean as well. Yeah, I think we're gonna do it like that. And pretty much what we want to check is this one. We want to keep sign. Is intersecting plane. I think Right. And then we do false. Otherwise, don't we get an error here? Maybe we don't. I'll be right back real quick. Okay, back. Sorry about that. Let's see. And then we just add triangle. Okay. Okay. And then I think we have... Yeah, then we can get down to here. We're gonna add triangle. Do I have this one? Yeah, add triangle T, add vertex V. Okay, let's see. Mesh parser. Get. And then we have slice. But I want to add here. So public void. I don't know if I want it as a boolean just yet, but we're gonna do start with void vertex V. It's a little bit weird adding a empty vertex. I'm not entirely sure how, but we can wait with this one actually. Add a triangle. And we want to make sure that we don't have duplicated vertices here. At least when we add triangles. Otherwise, we might be getting vert map, add vertex, try get value. Yeah. Is this how we want to do it? I don't know. Maybe. The idea is that we add triangle to this list. We added this information as well. So this one pretty much. Relationships. Yeah, I think we're gonna have public, dictionary, primitives, vertex, int. Yeah, vertex, indices. Is there any reason why this one is public? Mesh parser tester. Probably. That's probably why. And let's keep it public. And this one as well then. Vertex indices. And we're gonna do, here we do vertices add. I'm not so sure we want to do unique. Or do I want to remove unique or duplicated vertices here as well? It might be weird to not do it here and do it when we add vertices like this or triangles. Vertices mesh yeah. Okay. Yeah, we can probably. In fact, do we want to fix this first and then go through this one and remove duplicates? Maybe. Maybe. Yeah, I think so. Probably want to do it before we create the triangles, otherwise we're gonna have to recreate those as well. Or actually, no. It's easy to keep the vertices unique when we create it on the run. Fuck it. Let's do it like this. To do. Satiate. Okay, add a triangle. I want to take this one. So this is where we fill up triangles per edge. And we're going to make a little bit of a private void. What do we want to call it? Basically, I just want to take, yeah, this one and put it in its own method because we're going to call this one multiple times. Actually, no, fuck it. We want to do this one as well. So we're just going to call it private void. You know what? This turned out pretty good. I think we're just going to take... The fuck? We're just going to take this. And add triangle. We'll see. Maybe. Because the thing is, we already have the vertices added here. We don't... Fuck, how do I want to handle this? We pretty much want to do exactly this, but we want to do some other stuff as well. So let's put this one like that, and then... because I want to do this. You know what? If we have this, why even have this? I don't want to allow for duplicated vertices in any capacity. So yeah, we might as well remove this one and just do the dictionary. This is more and more turning into like a modeling software program within Unity. Maybe remove vertices and we'll only on. I'm gonna need to think on this a few more times before I jump on a solution. So we add a triangle here, and then we add vertices. And then triangles per edge. Do we want to have triangle get edges, get random point? You know what? We want to do, if it contains it, then we want to do some stuff. Otherwise, we do something else. Okay. Yeah, basically what I want to do here is something like this. Like, if we have it in the dictionary, then we want to alter the vertex, right? So I think, can we do it like this then? Pretty much what I want to do is this. If triangle if vertex index dot contains key triangle dot v1 else. So if it contains the key, we do triangle dot v1 is equal to, but set is private here, so we can't do that. In fact, we want to recreate it. Maybe before we add it. Or would that be stupid? Oh, that is, yeah, we probably want to recreate the full triangle because we create the edges in here as well. So before we add it, this feels a little bit insane. But this would look pretty much like primitives dot vertex v1 is equal to Nah, I'm not sure I like this at all. Maybe we can do a function where we change set vertex maybe. Oh, fuck yeah. And then we do get, and then we have public void set vertex, vertex, and then we do int index. Could we do it like this? It's not pretty. Ah, we can do it like, what was it? Terrain, data. Yeah. So add triangle. Yeah, we do this, but then we do 4. And then we do if vertex indices contains key triangle I. I don't know, it's a little bit... It's not as readable if we do it like this. Might want to rethink this one, we will see. If it contains the key, then we do this, otherwise we do something else. So if it contains the key, what we want to do then is we do triangle I, it's equal to, in fact it's not readable at all. It's almost like, I guess I wouldn't, it would be better if we did like vertices. We'll see. The grades. But anyway, the functionality will be the same. So triangle I is equal to vertex indices angle I. No. Yes, and once again, it's not only the triangle we want to change, but that's okay. We can fix that here. Ah, fuck, this is complicated. It's pretty much this we want to do. It's not really possible with this setup, so what can we do instead? Or you know what? We could... We could keep them like this with dirty vertices, pretty much, or vertices with the wrong index. And then in the end, we just read here, but that's also weird. But now I'm wondering if a solution like this is the way to go. Vertex v1 is equal to vertex indices dot contains we do it like this instead. If vertex indices dot contains key vertex return vertex vertices vertex indices vertex, else int index is equal to vertices dot count vertices dot add vertex and vertex indices dot add vertex index. Finally return just the same vertex. Is this weird? It's unoptimized as hell though, I reckon, because what we're gonna do now is see where I'm going with this. I'm not sure. But you know what? Maybe. Maybe. There's like, this is a lot of calculations here. I think we can do it like this for now. So if we structure it like this, we should be able to, like, we're gonna fill up this one by adding the triangles. So I think, yeah. Yeah, I'm still not sure about this. it's probably the better way to do it, I guess. But yeah, I'm not a big fan at all at like recreating vertices all the time like we do here. It's weird. Okay, I think we're gonna have to think up a better way to do this. So the reason we're doing this, or the reason we have this one, is because we want to remove the possibility of duplicated vertices when we do the slicing. Makes me wonder if this is starting to be so complicated that using class might be a better option. But with implemented comparisons like this, would that be weird? Yo, what's up, High Wall? You know what? Unfortunately, my time is running out for today. But we're gonna continue this tomorrow. Hopefully, I will have an answer to exactly how to approach this tomorrow. If I don't, we will figure it out tomorrow. But it would be nice to have an answer to it when I start streaming tomorrow. I think this is starting to shape into a very nice mesh parser system, and eventually mesh alterer system. It's pretty much only this part I'm not that fond of right now. But yes, we will continue this tomorrow. Thank you so much for watching, everybody. Appreciate it, and have a great rest of the day. Peace.